Hey, this is a video for 4.3a, soil composition and properties, particles. So go ahead and check out the overview and set up your guided notes. So one of the mineral components of soil are three particles, and we identify these three particles based on their size. They are sand, silt, and clay. Now the first one is the largest, sand. Now if you think about sand, you think sand, a grain of sand is really, really small. But actually in terms of soil particles, sand is the largest. Because it is so large and there's going to be a lot of spaces between the particles, it will promote drainage. It will also limit compaction. Now, compacted soil is when you reduce the amount of space between these particles, and this can happen from heavy machinery, for example. So when you drive a lot of tractors on top of soil, like for agricultural purposes, you can compact that soil. It makes the roots unable to penetrate the soil, and it will be difficult to grow crops, or any other plants for that matter. Now, silt is the medium-sized particle, and this is the relative size of silt to a particle of sand. Silt will promote water retention and air circulation. There's not a whole lot that you're going to be asked about with silt. You're going to be asked a lot more about sand. You're going to be asked a lot more about clay. Clay is the third one. If you notice, clay is very, 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 very small particles. These particles also have a negative charge. Just a little note, the clay particles are not actually circular shaped. They're going to be smaller, like more oblong shaped or like a pancake type shape. It's going to be kind of flat. And these negative charges will attract water because water has its polar molecule. So the positively charged hydrogen atoms are going to be attracted to the negatively charged clay particles. But in addition to water molecules, you'll also have some of these soluble cations or these nutrients. Calcium, magnesium, potassium are three examples. And this will enable clay to have very high levels of cation exchange capacity. What that means is these are cations, and this will allow the clay particles to hold on to these cations and exchange them with the plant. So the plant will be able to obtain water with some of these nutrients that are dissolved in the water, and it will be readily available for the plants. However, if you put too much clay, you're not going to get the water to drain through the clay because of the porosity and the permeability, which I'll talk about in a second. But also the sand, just to make a note, the sand is going to be the largest portion. Our soil in New York is very sandy in Brooklyn. This will allow the water to drain. So we really won't have a lot of standing puddles. The water will absorb down into the soil. You probably noticed this if you've gone to the parks and it's raining. There will be some areas, especially if you go to the ball fields in McCarran, there's some areas where they have the baseball fields. There might be a little bit more clay in there, and some of the water is standing after it rains, but most of the other places, there's not a lot of standing water. Now, I talked about porosity and permeability. The definition of porosity is it's a measurement of the open space. So the open space would represent all of this blue in between the particles. And this allows air, this allows water to go in between these soil particles. Now, just because something has high porosity doesn't mean it has high permeability. And the permeability is the measurement of the flow of water. So how long will it take a given sample of water to flow through a particular soil sample? Now, clay could be represented by example A. Clay particles are very small. But they are very small. They do have a lot of space in there. Because the particles are so small, there's still going to be, you see, there's a lot of blue in here. So it will have high porosity. However, clay does not have high permeability. Because it is so small, the water is going to be held to these clay particles. So water does not readily flow through clay. If you have too much clay in your soil, you will not have a lot of water holding, or will have too much water holding capacity, and the water will not be able to flow through the soil. The soil may become waterlogged and your plants may die because the roots do not have access to oxygen. Another thing is sand is going to have high porosity, but it's also going to have high permeability. So water will readily flow through sand. If you have water that flows too fast through the soil, you want to add some clay. If you have soil that does not absorb water, you want to add a little bit more sand to open up that pore space and to improve the drainage. Okay, so what I would like you to do is practice by completing the Check for Understanding and practice problem set 4.3a. I hope that this video is informative. I thank you for your attention, and I will see you soon.